your lab notebook. Is that clear? Okay, now the first thing is the purpose. What was the purpose? And the name of the lab is, it's a density lab. It's a density lab. All right, and the purpose of my lab is to determine the density of a regular solid, an irregular solid, and a liquid. Now, what are the materials that I need for this lab? Can somebody tell me? What are the materials we need? Graduated cylinder. Graduated cylinder. You can even mention that you used a 100 ml graduated cylinder. You also used a graduated cylinder. For the liquid, you used a smaller one, right? Graduated cylinder, 10 ml. What else do you need? Yes. Scale. Scale. What else do you need? The regular object. What else do you need? Regular object. All right. In our case, it was a cube, and then the irregular object, and then water. Is that right? Those are the materials we need for the lab. You should list. All right. Water. Can I say about 100 ml maximum? Right? 50 is more than enough, but I just say 100 ml. So you should be able to list everything. Even for your science fair, you should be able to list the materials, the amount that you want, what is the graduation on the equipment that you're going to use. Does that make sense? All details must be listed. The next thing is the procedure. Now, procedure can generally be abbreviated. All right? So, procedure. And I'm going to say the first thing, I'm going to let you write out determining density of a regular solid and a liquid at home. I'm going to model one with you. Is that correct? All right? You will finish the other two parts at home. So I'm going to say procedure to determine density of irregular solid. To determine the density of an irregular solid. Okay, that's the one that I'm going to go over with you. So what was my step number one? Can somebody tell me, what did we do? We right away started putting water into the graduated cylinder. Was that our step one? What did we do first? We found the mass of how many rubber stoppers? All 5 rubber stoppers? All right. So mass, okay, mass, 2 rubber stoppers, followed by 3 and 4 stoppers, and record their mass. Is that right? In data table, right? So when you know you have to record, you have to be sure that you have a data table to record. Is that right? As you do your science fair project, you should know what the procedure is. Unless you have the materials, can you buy them all and be ready to do your project? No. You need to know how much of each material you need. Is that right? The next thing is, yes, I'm going to write a procedure, but when I'm going to record, am I just going to scribble numbers whenever and wherever I like? No, I need an actual data table. So you should think, what are the numbers I'm going to put into my data table? What should my data table look like? Now, I gave you the data table for this lab, right? You should be able to make a similar one for your science fair project. Does that make sense? That can contain all parts of your data. Okay. So I did that. I recorded it in my data table. What's the next step? What do I do with the graduated cylinder? Add how much water? Add enough water in the graduated cylinder to submerge all 4 rubber stoppers. Can I say that? All right? And record the initial volume. Is that right? Record the initial volume. Then what do I do? What is my next step? All right, slide the stoppers. Slide 2, followed by 3 and 4, followed by 3 and 4 stoppers, and record the new or final volume. Record the final volume in each case. Is that right? I'm done with the lab. Is that right? What else do I have to do?
The volume of the water
So, and then finish your calculation. Calculations is not a part of the procedure. Is that right? Calculations are calculations. Right? That's enough. I have 3 steps and I'm finished with the lab. Is that right? Now, let's come to the data table. All right? And you can say, calculate, if you want, calculate the density. All right? Calculate the density. Okay? Now, let's go to the data table. Now, I don't remember what kind of a data table I gave you. Can I borrow one so that I'm in sync with you? I will often write differently in different classes. All right. So I have mass. I have initial volume of water. Initial volume. All right. And then I have final. And then I have volume of water displaced. And then I have the density. Is that right? And these are my trials. Is that right? Trial number 1. What happened? Trial 1, 2 and 3. 2 and 3. Correct? All right. So I collected my data. I know you all have your own data, but I'm going to use my data and work with it. Okay? You can actually work with your data if you want, as you watch me work with my data. Does that make sense? Now, I have, this is the rubber stopper. Okay, so I had 8.20 grams for 2 stoppers, and then I had 12.27 grams. It's in grams. I'm measuring the mass in grams. I'm measuring the initial volume in ml. I'm measuring the final volume in ml. I'm measuring the volume of water displaced in ml. How do I calculate density? Density is what? Mass divided by volume. So the unit of mass is what? What is the unit of mass? Grams. What is the unit of volume? Milliliters. What is my final density unit? grams over milliliters. Okay. So now I do realize kids are looking at the clock and they're like, she's not going to give the quiz. That is correct. All right. Um, so I'm not going to give the quiz. All right. The quiz is postponed to the next class. All right. But I need you to have a lab notebook before you take the quiz. Does that make sense? And I need you to write all the lab completely and bring in the lab notebook. Now, could I read two numbers past the decimal with my scale? Yes or no?
No.
You couldn't read two numbers past the decimal with the scale that you had?
Yes.
But, really?
Yes.
Okay. Did you watch? You can go get it. Go and see if it reports two numbers after the decimal.
I remember now.
Okay. Look at your data if you're a little confused. Now, let's look at the graduated cylinder. All right? The graduated cylinder was a 100 ml graduated cylinder. I could definitely read the markings between 50 and 60. I knew what was 51, I knew what was 52, and so on and so forth. Is that right? When I record, I know my certain digits, and I need to record one more estimated digit. Is that right? So the initial volume was 56 ml, 56.0 ml for me. Did you record the 0.0? That makes my graduated cylinder have three significant digits. Is that right? My final volume was 62.0 ml. And now I come to the amount of water displaced. Is that right? Did you all record to the correct sig figs? Okay, now as I subtract 62.0 minus 56.0, what is the rule when I subtract? What is the rule when I subtract? What rule of sig fig should I follow? The least number past the decimal. Is that right? Or to the least precise number. Is that right? So, in this case, it works out to be 6.0 ml. If you do not write the 0.0, am I going to take points off on your lab test?
Yes.
Yes. You are not subtracting to correct significant digits. Does that make sense? Now, moving on, I have to calculate density, which is mass, and this is volume. Is that right? So 8.20 grams divided by 6.0 grams. And what does the calculator give? Can somebody put it into a calculator and tell me what the answer is? Farah, what do you get? 1.36. 6 repeating. Can I report that as my final density?
No.
What should I do?
1 grams is 4.
Grams? Is that the mistake? What is the mistake? What if I write out my calculator answer like that? What's wrong?
Grams over milliliters.
There is no sig fig. It's not reported to correct sig figs. It doesn't contain units. So how many sig figs must I report this answer to? 2. This is the least. Is that right? So I need to report my answer to 1.4 grams per milliliters. Do you understand? So if I see you calculate density, all right, and if I see you not reporting the final density, not looking at sig figs, when you multiply and divide, or when you subtract, I'm going to take points off in your lab test. Is that clear? So now moving on, all right, when I put 4 stoppers in, I actually got a volume of water displaced as 12.0. That was 4 sig figs. This was 3 sig figs. So I got my density to be 1.35 grams per milliliters here, and this was 1.4 grams per milliliters as well. Okay? So now I'm supposed to find my average. Okay? So let me teach you a new rule for sig fig that I haven't taught you so far. Okay? So I'm finding my average. I have 1.4 for the first trial, 1.4 for the second trial, 1.35 for the third trial. I add them all and divide by 3. Is that right? But my volume was 12.0. The display's volume was more. It is 3 sig figs, so I have to report 3 sig figs. So can you put this in a calculator and tell me what the average is? What is the average? Yes, Jessica, what do you guess? Just give me the calculator answer. 1.3833. All right? Now, when I add to the least number past the decimal. Is that right? Now, one thing you have to remember, kids will look at this 3 and say, that is 1 sig fig. So should I report my final answer to 1 sig fig? No. You report your answer to 2 sig figs, all right? Because when you add, it's the least number past the decimal. Is that right? So when you add up, all right, it will so become that this will become 1.4 will be your answer, all right? Why isn't the 3 included for sig fig? Remember, perfect counting numbers have infinite number of significant digits and they don't count. If I say there are 10 students in this class, is there any discrepancy in the reading? Is there a certain digit and an estimated digit? If I can actually count out 10 students, is there any uncertainty there? Or is there an estimation there? No. Whenever I'm counting out and I am sure, especially counted numbers, do not count for sig figs. Only measured digits count for sig figs. Or if I'm estimating a huge population, that will come into sig figs. Does that make sense? Where I'm estimating. You understand? When I count perfectly, that doesn't count for sig fig. So this answer reported to correct sig fig will be 1.4 grams per milliliters. Do you understand this process? Do you understand this lab? Now, let's go to some of the errors, all right? The error analysis in this lab. Now, what are the possible errors? What do you think are the possible errors in this lab? Anybody? Yes. But if you don't read the graduated cylinder, that's a human error. That doesn't actually count as a source of error, all right? You can always go back into the lab and read it correctly again. Is that right? Now, there was one thing Mr. Martin said yesterday when we were talking. When you took the 3 rubber stoppers and you masked it, then you put the 4th one, then you put the 5th one, right? Now, what he was telling me was kids are not putting, now this rubber stopper is bigger than this rubber stopper, all right? Should I drop the seam 3 and get the volume? Or after I put the 4 and 5, now I in the world do not know which is the first 3 I measured, I just choose these 3. Would that be a right thing to do when you measure for the given mass versus the displaced volume? Do you think you can do it like that? That is the source of error, all right? Now, when kids were sliding in, so you need to get, that's a human error too actually if you ask me, right? But if you oversaw that, you're likely to get different answers for your different trials. Does that make sense? Because your volume and your mass do not go together. You took the mass of 3 rubber stoppers, but now you're taking the volume of 3 other rubber stoppers. Does that make sense? All right? So that is the source of error. All right? So talk about matching up the rubber stoppers, mass, and its volume. All right? Mass versus volume. Now, for me, this is also human error. All right? When I saw the kids slide the rubber stoppers in, Did you find air bubbles in it? Did you notice any air bubble in it? No? There are air bubbles, alright? So, especially you do things real quickly, alright? Alright? You see air bubbles coming up? Alright? So, there will be air bubbles. I can still see air bubbles sticking on. Do you see the air bubble on top here? Do you see the Jacksons? Do you see the air bubble sitting on top of it? Do you think the air bubble will make a difference in your volume? Yes. It is a source of error. Alright? You can tap it, you can do things, but you can't control it altogether. Right? That is outside. You try your best. You try it as gently as possible. Alright? But that is a source of error. Alright? So, any other reason why a different student got a different... Why do you analyze results? Why do you do that? To improve. The next time, you should get consistent results. Is that right? There are other errors. Do you know for sure your scale masked accurately? Do you know it's not wrong in its measurements? Do you know such things? Those are again out of your control. Is that right? You can get precise results in the lab. Is that right? Now, so those are the sources of error. You should know how to calculate percent error. Did I go over the formula for percent error with you? No? So it is actual minus experimental divided by actual times 100. Okay? So let me tell you, I'm saying I should have gotten the actual value of the rubber stopper should be actually 1.3 grams per milliliters. What was my answer in class? I said it was 1.4. Is that right? So what's my percent error? 1.3 minus 1.4 divided by 1.3 times 100. What do these two lines mean? Absolute value. Am I bothered that it is a negative number? No. So I do 0.1 by 1.3 times 100. Is that right? Right? So how many sig figs? How many sig figs? Just one sig fig, right? I can report it. 100 doesn't count for sig fig again. Alright? In percent, there are no units. It doesn't count. So what's my percent error? Can somebody put 0.1 divided by 1.3 times 100? What's my percent error? Yes?
7.692307.
7.69. So I'm going to say 7.7%. Make sense? Or 8%. Okay? Does that make sense? Do you understand? You will be asked to calculate percent error on your lab test. And you should know how to do it. And you can have the formula written down in your notebook. Okay?
So Reggie did
Guys, I still feel you're not solid on sig fig. Alright? Please practice sig fig and make sure you know the density that well.